Hello friends, welcome to Shiksharthi. In this video, we'll be discussing the solutions of the second assignment. So let's start. So starting off with the first question, and if you have already done the first assignment, you would see that this question is the next level of the first question which appeared in the first assignment. So, as advised, before we begin with the test, what are the few checkpoints before you begin the test? So first, you will start off with screening the questions in a matter of 1.5 minutes. And once you have screened the questions, then you can start off with the questions in any order. Though it is advised that even after screening the questions, you need to start off with the question that you feel is the best question to start with, so that it gives you enough confidence for the remaining questions to follow. Okay, so now talking about the first question, we know that there are if I talk about three types of entries or exit. So the question talks about, so the question says, a room has 2 windows, 3 doors and 4 big holes. Each of these are accessible to humans, and there is a thief who's standing outside. So talking about the first question, the first part of the question, it says he can enter or exit the room in how many ways? So once I know the ways, I know that when it comes to the word or, as discussed earlier, so or is mutually exclusive, and gives you the point of intersection. So when I am talking about in how many ways can a thief enter or exit, let me first talk about what are the total points. It is just like saying D plus H plus W. And even before I begin this question, and if I say that the question is on calculations, how can I associate this question with calculations, though at the very outset it looks to be a question on permutation combination. So permutation combination and calculations, they go hand in hand. That is the point that we are trying to make by giving you this question. So in the first question, part A, we need to see these are the total number of points in which a person can either enter or exit. Right? So I know that this is equal to what? The entry points, and this is equal to the exit points also. So what are the total number of ways? Or means what? Addition. So can I say this will be nothing but twice of D plus H plus W, which gives me the answer as 2 into 9, which is 18. As discussed earlier, there are 2 ways of doing a question. One is the basic way and the other one is the best way. The basic way is definitely a way in which you would want to do the question, but maybe a time consuming way, but the best way is a time saving way. The choice is yours, because it all depends on the presence of mind, the time when you are attempting the question, which is the way that you are going to adopt. Though if I have already done this question earlier, as you have already done this question earlier in assignment 1, so here you should be adopting the best way of doing part B. So this was part A. So talking about part B, we can simply say what? It is just like trying to say that you are supposed to find out the square of a 3-digit number. And why do I say 3-digit number? Because there are 3 basic points, the 3 points of accessibility. The basic points of accessibility are 3 in number. So now this gives me the answer as 9 square, which is 81. So you want the basic way? Refer to my first video wherein we have made cases. And how many cases are you supposed to make? That is already given in the first video, and you can always refer to it. Okay, talking about the second question. Now the second question talks about how many double-digit cubes can be formed. So many a time you would see that the questions are given and language increases or decreases the comprehension level of a question. So in this case, this question is no different from had it been asked that how many double-digit numbers can be formed. I'll repeat. What I mean to say here is, if the question would have been how many 2-digit numbers can be formed, is the same as the question that talks about how many double-digit cubes can be calculated. So we know that if I had to form a 2-digit number where t is my tens placed digit and u is my units placed digit, I know that t can take any digit from a 1 to 9, which is just like saying 9 possibilities. And then u can take any digit from a 0 to 9, which is just like saying 10 possibilities. So how many such numbers can be formed? 90 such numbers can be formed, the cubes of which can be calculated. Right? So this question is a fairly easy question. Question number 1 becomes fairly easy had you done this kind of question earlier. But if you're doing it for the very first time, maybe question 1 is not that easy. Okay, talking about question number 3. So at the very outset, it talks about an octal number. An octal number 7 is added what? 7 times. So if you have not done such kind of questions earlier, this is not the question to be attempted in the very beginning. But if you have practiced such kind of questions, for example, I can relate this question with a video of mine which talks about special multiplications. Now in special multiplications, we have talked about many things, and among those things we have talked about multiplying it by a 9 or a number which has all 9s in it, 9s as digits in it. I can relate it with this. How? Let me exhibit that. So if you want to see that, you need to refer to my video on special multiplications, part 1 and part 2. Okay, so here if I say, forget about the base for the time being, whether it is a decimal number or an octal number, it does not make any it does not make any difference if I say if 7 is added 7 times, is just like saying 7 into 7. Now taking it to a next level, if I add x 7 times, what will you say? It is 7x only. We are doing the same. Now the value of x here is 7. So 7 into x is 7 into 7. Now coming back in the realm of the question. So now when we come back to the question, it talks about this is an octal number. Now the moment I see this, I am able to relate that I should write. Now let us imagine that this is my multiplier. And let's say this is my multiplicand. And this is my multiplier. So what will I do? I'll write one digit lesser than the multiplier, which is 6. And how much do I need to add to a 6 to get 7? 6 1 is the answer. It is just like saying, if the same thing would have been asked in decimal number system, I would have said that this is 8 followed by a 1. And what is the logic that I'm using? Now here I am having a number which has all 9s in it. For example, if I would have multiplied a 9 with an 8, I get what? 7 followed by a 2. So let us say here the multiplicand is 9 and here the multiplicand is 7. Now you are multiplying. Here the multiplicand is having all digits as 7 only. In this case, octal number system. And here the multiplicand is having all 9s in it. What am I supposed to do? I am supposed to write down one number lesser than this, which is 7. And how much do I need to add to a 7 to get a 9, which is 2? I am using the same logic here. 1 lesser than this, which is 6. And how much should I add to a 6 to get a 7, which is 6 1. Taking this thing forward, if somebody would have given me a question like a 7 7 multiplied by a 7 in octal, how would I do it? I would write one number lesser than this, which is 6. But since this has 2 7s in it, I would write it as 0 6. How much should I add to a 0 to get a 7? 7. And how much should I add to a 6 to get 7? 1. So the answer would have been a 6 7 1 in base 8. Base 8 means octal number system. Okay. Talking about question number 4. A similar kind of a question had been given in your assignment number 1. Please refer to it. We can save time on this. But just to give you an insight here, the basic thing. Now I am supposed to form a 3-digit number, and I'll assume that the 3-digit number that I am forming here is HTU, where H is my hundreds placed digit, T is my tens placed digit, and U is my units placed digit. And the question talks about, this is the condition given in the question. The hundreds digit is greater than or equal to the units digit. So first we need to make cases. What are the cases that we will be making? Hundreds digit being a 9, in that case let T be T, the tens digit be T only here. And I know that the units digit can be a 0 to a 9. Hundreds place can take a 1 to a 9. Units digit can take any digit from a 0 to 9, and so with the tens digit. But at the same time, I need to obey this condition which is given in the question. So you make all these cases, wherein the hundreds placed digit can vary from a 1 to 9 and the units placed digit given on the condition will be varying from a 0 to 9, 0 to an 8 in this case, 0 to a 7 in this case, and the last case will be 0 to 1. So how many such numbers will you get? 2, 3, 4, 5, 6, 7, 8, 9. Now when you add all such cases, the answer comes out to be 54 such cases. Now you will get 54 such cases wherein your hundreds digit will be greater than the units digit. But then how many values can I give to t? I can give 10 different digits to a t. So how many such numbers can be formed? 540. So please relate, few minutes back I talked about permutation, combination and calculations. They go hand in hand and they can be combined at any given point in time. Right? Okay. Talking about question number 5. So question number 5 talks about a product of 3 numbers such that this has A digits, this has B digits and this has C digits. The number of digits here are A, B, C. Now by including a parenthesis here, I am trying to signify that these are the number of digits which these numbers have. What is the best way of attempting the question? So at the very outset, the question may look to be difficult, but if you have practiced such kind of questions or if you have watched the video, my video wherein I have talked about when I multiply two numbers, how many digits can a multiplication give. I repeat, there is a video of mine wherein, there is a video which talks about if I multiply two numbers, how many digits will it give? Okay, so can I say that if I am multiplying two numbers A into B such that A has A digits and B has B digits, what is the maximum number of digits this product would have? A plus B. What is the minimum possible digits it would have? A plus B minus 1. You want to take examples? Okay, take this as 1, 1 each, because the question does not talk about that these numbers A, B, C are 3 different natural numbers. It talks about these are 3 natural numbers, right? So I can take both of them as equal. Let's say I take them as 1 into 1, right? And I'm taking the number of digits also as equal. There is nothing that can stop me here. Okay, and then a maximum possible single digit number that I can take, which is 9 into 9, right? So I can justify this answer. Similarly, now once I know, I can write this A into B is equal to K. So K has how many digits? A plus B or A plus B minus 1? Now C has C digits. So as done few minutes back, now let us say that I am multiplying two numbers. Now this number has A plus B digits and this has C digits. So K into C will give me a maximum of A plus B plus C digits, or it will give me a minimum of A plus B plus C minus 1, using the same logic as used here. But if K would have had A plus B minus 1 digits, in that case A plus B minus 1 plus C, which we have already taken, and one more case here as A plus B plus C minus 2. This is the basic way of doing this question. So as discussed earlier, the basic way would always make you consume time. So I need to have a time, I need to have a tab on time as well. Now let's say if I cannot understand how to attempt this question, what is the best way? Substitute the values. What are the values? Take A is equal to B is equal to C. When I say A is equal to B is equal to C, I am saying assume the numbers also as the same and assume the digits also being as the same. So this is just like saying you took a 1 digit and finally it gave you 1 digit only, which is just like saying 1 plus 1 plus 1 minus 2, 1 digit only. This case proved. Second, this is 1 digit plus 1 digit plus 1 digit is giving me 2 digit, which is just like saying A plus B plus C minus 1. And this is 1 plus 1 plus 1, which is giving me 3 digits. So the best way also gives you the same answer and the basic way also gives you the same answer. Choice is yours, and it is all dependent on your presence of mind and the practice that you would have done earlier regarding such kind of questions. So in a test which you are appearing for the very first time, I mean, naturally the test that you will be giving at any given point of time would be the first time when you are appearing for it. Be prepared for the unprepared. I say this with a lot of responsibility. Be prepared for the unprepared. Now when I say this, you will not be discomforted. I mean, when you are already prepared for the unprepared, the anxiety levels would be low and your presence of mind would be on the greater side, which is expected when you are writing a test for the very first time. Okay, talking about the next question, and it talks about what is the coefficient of a square in this. Please relate, this is nothing but we have discussed this thing in one of my videos also, which is God of Maths, and in other videos also wherein we have talked about multiplication, squares, special multiplications. From anywhere you can pick this up. So which is just like saying this, assume that this is just like a 3-digit number, assume that this is just like a 4-digit number, the square of which needs to be calculated. So can you calculate the square of a 4-digit number? Though you have not done it, but as I said few seconds back or few minutes back, that be prepared for the unprepared. You know how to calculate 3-digit squares. Can you attempt a 4-digit square? Yes. Starting off with this, assume. So 9 square is an 81. Twice of, thrice of, 4 times of 81. And then their symmetric values. So this is just like saying this is 81 times of a to the power 0. This is the coefficient of a to the power 1. This is the coefficient of a square. This is the coefficient of a cube. Coefficient of a to the power 4. Coefficient of a to the power 5. Coefficient of a to the power 6. This is just like saying this is the coefficient of a to the power 0, a to the power 1, and this is the coefficient of a square. What are you supposed to calculate? You are supposed to calculate that in this addition. So indirectly or directly the question gets converted into a question on calculations. This is essentially what we have been doing. And you would see that, I mean, if you give it to me, I would calculate every topic, or I would convert every topic of mathematics into calculations. And I mean it. Okay, so here coming back, coefficient of x square 243, coefficient of, a square, I'm sorry. Coefficient of a square here is 9. How much is 243 plus 9? 252 is the answer. Moving on to the next question. These kind of examples also have been taken in the videos which were suggested as tasks to you before this assignment was given to you. So using the connect directly from there, now if I start off with 100%, the very first discount means what? I'll be left with 90% of its value. Then I'll be left with 80%. 100 minus 30 is 70%, and 100 minus 40 is 60%. And these are successive discounts. So successive means I'll be multiplying them. Now this comes out to be a 3024 divided by 10,000, which in terms of percentage can be written as 30.24%. That means the original value of the item, if it was 100%, now the value of the same item after offering 4 successive discounts is 30.24%. Let us see what is the question that is being asked. It reduces to a, so it reduces to a 30.24%. It does not say reduces by. Had it said it reduces by, then you would have subtracted 30.24 from 100%, in which the answer would have been 69.76%. And you would see that in the second assignment, I have started giving you questions, or we have started giving you questions having choices, so that you get an exposure to all kind of questions. Questions in terms of fill in the blanks, questions without choices, questions with choices. Yeah, let's move on to the next question. Question number 8. In a certain way, you have already done this question earlier. So if you would have done this question earlier, this question becomes easy to attempt. Else, it should not be attempted in the very beginning. So there is a lot of analytical reasoning that is involved the time when you think of solving this question. So if I were to solve using the logic that has already been used in the video solutions of assignment 1, I can directly come down to an answer, but then for the sake of explaining it in entirety, I'm taking the discussion once again, the basic discussion. Now, the basic discussion says, had I taken a 2000 whole square. Now, even before I say this, a 4-digit whole square will give me how many digits in the answer? It will give me either 7 digits or 8 digits. From where does it come? It comes from here only. We have already discussed this. If I multiply a 4-digit number with 4-digit number, what is the maximum count of digits that I can get? 4 plus 4, which is 8, or 4 plus 4 minus 1, which is 7. So using the same logic. So you will see more or less the questions given here can be connected. Okay, once you are able to establish this, let us see what is the value of D that I can deduce from here. The value of D here becomes 8 digits. Why? Because the question says the smallest possible 4-digit number, the square of which gives me maximum possible digits. Okay, so now 2 square gives me what? 2000 square gives me 4 followed by 6 zeros. Had I taken 3000, this gives me what? 9 followed by 1, 2, 3, 4, 5, 6. Here also should be 6. So 1, 2, 3, 4, 5, 6, 7 digits, and here also you are getting 7 digits. Had I taken 4000 whole square, what is the count of digits that I would have got? I would have got 8 digits in total. So can I say from here, whichever number this is, this has to be a between 3000 and 4000. Right? The next step here is, the moment I say that it is a 3000. So here, even before you begin, you need to see that, okay, now can I prototype the value of thousands place as 3? Yes. Now in that case, can I put these values, because the minimum starts like this only, and this I'm putting it as this. So in this case also it is what? 961 followed by 4 zeros. So this is nothing but 961 followed by 4 zeros. But if I take 3200, this will be 1024 followed by 4 zeros. That means, can I say that now the number that I'm supposed to form here will be between a 3100 and a 3200. Once you have done this, then you further need to introspect. So it is just like saying this, dash dash. On a further introspection, you will say this will be this, and then on a further introspection, you will say that it had to be a 3163. How? Please try and reason it out on your own. If you see that we had already done, have we done this question earlier? Yes, we have done this question earlier in assignment number 1, wherein we talked about 316 whole square. The same logic could have been used here. Now 316 whole square is just like saying a 3-digit square can give me a maximum of 6 digits and a minimum of 5 digits. So 316 is a maximum possible number, the square of which gives me minimum possible digits. Had I known this, I could have immediately filled up the blanks here, and I would have said that the number should have been a 316, and then I could have iterated the values of the units place, which is either a 0, 1, 0 to 9. Had I known how to calculate 4-digit squares. Else, this becomes a very exhaustive question, and as advised earlier, such kind of questions should be avoided if you have not done such kind of questions earlier. Okay, talking about question number 9, part A, which talks about A plus B plus C plus D whole cube gives how many terms? This is a very exhaustive question. If you wish, you can do it by calculations also, as explained in my videos. Another approach, which may be a better one here, is we can say that we have to distribute the power among these 4 variables. I'll repeat, we have to distribute the powers among these 4 variables. So there'll be cases wherein the entire power gets distributed among exactly one of these variables. How many such cases would you get? 4 such cases. Or now the power gets distributed like this, or like this. Can there be any other case other than this in which the power can get distributed? So you need to calculate all such cases wherein the power gets distributed like this. You will even have a case like I'm just giving you a specific case. You'll be having cases more than these. So now what are we saying? We are saying, can I say here I can get 6 such cases? Here I will get 6 such cases, and then I need to see how many cases would I get here. If you say no, I cannot reason it out, I need to write it down, you can write down all such cases. Without writing also you can think that what are the total number of cases that you can get. How? Can I say here I just need to choose any 3 out of 4, which is 4p3. Here I just need to choose any 2. And here I was just like saying what? You had to choose any 3 out of 4. Okay, how much is 4p2? It's just like saying 4 factorial divided by. But if I say this, then I need to see that here if I am talking about 12 such cases, maybe the cases are already involved here. So you have to be very cautious when you are using permutation combination here. How to use a P or how to use a C. Now if somebody says no, I would not attempt this question because this question looks to be very, very difficult because it is on permutation combination. So let us simply adopt the principle of counting, right? So which is just like saying 4 cases here. How many cases here? It's just like, can I write down all the cases? One of the cases I have already written. What are the other cases that you can write down? So a to the power 1 along with either b square, c square, d square. Now b to the power 1 will be with what? C square or with d square, and c to the power 1 will be just like what? With d square. So how many cases have you written? 1, 2, 3, 4, 5, 6. And the same reasoning you'll do here. A square along with b1, a square along with c1, a square along with d1, then b square along with c1, c to the power 1, then b square along with d to the power 1, and then finally c square with d to the power 1. So again you will get 6 such cases, and the same you can do here, which is just like saying ABC, ABD, ACD and BCD. So if you don't want to do it by permutation combination, you can simply do it by fundamental principle of counting. You can just write down all the cases, or if you are great at calculations, even calculations can give you the answer quickly. How? You just need to see that if I am multiplying, now x cube is just like saying what? Square into x to the power 1. So it is just like saying a 4-digit square you are multiplying with a 4-digit number. Now a 4-digit square will give me what? Either 7 digits or 8 digits. And then you are supposed to multiply it with the 4-digit number. So do you know how to multiply a 7-digit number with a 4-digit number or an 8-digit number with 4-digit number? If you know this, then you can answer it with the help of calculations also. Have we discussed it in our videos? Yes, we have. Please refer to the videos. Okay. 9b. A single digit number is added to a double digit number and then finally to a 3-digit number. The best way to approach this question is take the minimum possible single digit, double digit, triple digit number. You get the answer as 111. Take a maximum possible single digit, double digit and a triple digit number. When you add this, you get the answer as 1107. So what are the total number of digits that you get here and digits you get here is the same as we have discussed it earlier. Okay. So now if I'm adding this, the question talks about what? The question talks about a single digit number is added to a double digit and then finally to a 3-digit number. The sum thus obtained has how many unique possibilities of the number of digits in it? So there are only 2 such possibilities. Either you are getting a 3-digit number or you get a 4-digit number. Please do not get confused with the options. They are talking about what are the total number of possibilities you get in terms of digits. So you have only 2 possibilities. One possibility is a 3-digit number that you can get because of the addition of all the 3, or you can get a 4-digit number because of their addition. Last but not the least, 10th A and 10th B are very easy questions. You should attempt it because you have done such kind of questions earlier. Even if you have not done, the questions which we may not have done earlier can also be attempted. Right? So I have given you the explanation. You can just refer to the explanation. I'm explaining one out of them, which is the second part. The second part talks about a cube root of a digit is taken, of a number is taken, and it results into a single digit number. So the best way here is take the cube root of 1, which is 1, take the cube root of 27, which is 3, take the cube root of 125, which is 5. So what are we saying? We are saying that in the original number there was only one digit, the cube root gave me one digit. 2 digits, the cube root gave me this. So can I say in the original number, had there been n digits, the cube root of that will give me either n plus 1 divided by 3, n plus 2 divided by 3, or it will give me n by 3. I repeat, if in the original number, let's say here we had 125, had 3 digits, the cube root, now this 125, 3 digits is equal to n. Its cube root is just like saying what, only one digit, which is just like saying 3 by 3, only one digit. So if the original number has n digits, its cube root will have only 3 possibilities in terms of the digits that it can get. Can you deduce this? Yes, you can easily deduce this by involution. What is involution? X square, the involution of x square is, the inverse is involution, is x to the power 1 by 2. The involution of x cube is x to the power 1 by 3. Okay, so I have used the same logic. So here I had 2 digits, its cube root gave me only one digit, which is just like saying 2 plus 1 divided by 3, which is one digit. And here in the original number I had only one digit, the cube root of which gave me only one digit, which is just like saying 1 plus 2 divided by 3. Talking about the first case, 10th A, there are only 3 possibilities of digital roots, and those 3 digital roots are 1, 8 and 9. You can check it out. Now, if you feel that something really informative has been discussed in this video, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us. Please do comment in the comment section in case if you want us to do videos on some specific topics. Thank you so much. Until next time we meet, goodbye.